Hi, my name is Tom and you are at level 29 in Mastering Einstein's Special Relativity. This episode is about proper time and this is the C level, not for all. We will actually derive the equation for proper time. Let's get into it. Let me move my mouse to here. Here we go. Proper time in action. Space-time diagram. We have three observers. Number 1, number 2, number 3. And currently we are in the perspective of observer number 1. Two events are happening. Event number 1 at 20 seconds. Event number 2 at 30 seconds. The delta time for observer 1 between these two events is 10 seconds. We can switch the perspective back and forth between observer 2 and 3. We've done so in previous levels, especially the B level of this episode, 29B. So here it is. So let's zoom in on the different perspectives. So from perspective 1, observer 1, it looks like this. Proper time will be the delta t between these two events, 10 seconds. From the perspective of observer 2, these events are in different locations and at different times from the perspective of observer 2. And the equation is proper time, tau, is the square root of a squared minus b squared. That's the formula. And that will also be 10, because proper time is a universal truth, something all observers agree upon. This is observer number 3. He sees the two events again in different locations, different times, different A, different B, but if he applies the formula, he will also get the same answer, 10 seconds, the delta time. So it's called proper time, but I think you should call it delta proper time or proper delta time. This is the link to the website where you can actually do this for yourself. Can we go there? Yes, we can go there. Let's have a look. So here it is. It's for you all to use. You can just go there and let me get my cursor here. You can put your cursor on the perspective slider, move it down for observer 2, move it up for observer 3. And here below you will find the equation for proper time. I could not put in a nice looking equation, but you see here square root delta ct delta x, and you will see it's always 10, no matter in which perspective we are. The delta t and the delta x's, they vary, but the proper time is always 10, no matter what you do. So that's proper time. Let's go back to this one again. Are we there? Yeah, we are there. Okay, let's derive proper time. Ooh. I'm going to use my secret notations. I will always tell you what is the event we are talking about and who's talking, because that's so important in special relativity. So this is the Lorentz transformation for location. And why did I drop X? Okay, yeah. Observer 1 will be the stationary observer in our point of view. And you can tell in the previous pictures that both events for observer 1 happen at the same location. X is 0. So the X of any of those two events will be 0, and that's why the x cancels out in this first equation. When we take the Lorentz transformation for time, we get this one, and now what cancels out? Yeah, again the x of that event number 1 or 2, from the perspective of observer 1 is always 0. So these cancel out and the formula, simplifies, you lose a term. This is gamma, you should know by right now, of course. And now let's look at the delta between two events through the eyes of observer 2, which will be the delta x between events number 2 and 1, comma, through the eyes of observer 2. If you do this with using the equations on top of it, you will see that you will get this equation. You will get minus gamma, which is the Lorentz factor, times the velocity of observer 2 through the eyes of observer 1, multiplied by delta t, the delta t between the two events through the eyes of observer 1, right? So this equation is easy. If you do the same for time, you will see that delta time through the eyes of observer 2 will be gamma, Lorentz factor again, times the delta time through the eyes of observer 1. So we just simplified the Lorentz equation and then we put in the deltas. So far, so good. Let's see, I'm going to repeat the equation for delta x through the eyes of observer 2. And then I can, just by taking this formula, right, you can see with the arrow, I'm just repeating that formula. But I can also say, well, the difference between the location of these two events through the eyes of observer 2 is the same as the velocity of observer 1 through the eyes of observer 2 times the delta time through the eyes of observer 2, right? So there we have it, v delta t. And I want to go back to the velocity of observer 2 through the eyes of observer 1, which is minus the velocity of observer 1 through the eyes of observer 2. If you switch perspectives between observers, you just put in a minus sign in front of the velocity. There we go. So now we are at this point. Let me repeat that intermediate result on the next slide. Oh yeah, I did two things. I put in the minus sign and I replaced the delta t with the equation which was on top of it, with the third arrow. So we have this, right? This is what we derived at previously. Now someone said, I don't know who, let's square delta t and subtract the square of delta x divided by c squared, where c is the speed of light. If you take the top two equations and just substitute them in the third one, you will get this. You will see that you can, you can take out delta t, gamma outside of the brackets, squared, and you get 1 minus v over c squared. And because minus v multiplied by minus v is again the same as plus v squared. So we get rid of the minus sign there, and we are left with the original minus sign. You can just do this with pen and paper, right? And then the last step is that gamma squared is 1 over 1 minus v over c squared. And now you multiply it with 1 minus v over c squared. So gamma squared cancels out here, so we are left with delta t squared through the eyes of observer 1. Now we can take the square root on both sides and we get this. So the square root of delta t squared minus delta x squared over c squared through the eyes of observer 2 equals delta time through the eyes of observer 1. And now you have to recognize the magic here. There's no Lorentz factor anymore here. There's no gamma, but much more important, there's no v. There's no speed, there's no velocity. I could have picked any observer for observer 2. So no matter what the observer is, if he does the math, if he takes his observations, squares delta t, squares delta x divided by c squared over and root it, he will get to a number that every other observer agrees upon. So let's apply it now. This is an event table. You know I like the space-time diagram, but I like the event table as well. So here we have two events again, could be any events. For observer 1, they are both in the same location, 0, 0, and they're 10 seconds apart. In this case, the first one at 20 seconds and the second one at 30 seconds. And then if you know what the gamma is, and you apply the Lorentz transformation, you can calculate the coordinate of event 1 through the eyes of observer 2, which is minus 26.666666 C, right? Just apply, get rid of intuition, apply the Lorentz transformation. You can also calculate the x-coordinate of event 2 through the eyes of observer 2. You will get to minus 40. You can also calculate the time of event 1 through the eyes of observer 2 by applying the Lorentz transformation. You get at 33.33333, and you can do this for the second event as well, and you get to 50. I'm not going to do it for the third observer. You can do this on your own. I'm sure you can. But if you calculate proper time using the observations from observer 2, and you put them in the equation for proper time, you will see you will get 10 again, no matter what. So I encourage you to do the same for observer number 3. Try to use the Lorentz transformation to get the numbers for the two events, the x and the t. Put them in the proper time equation, and you will see that also for observer 3, the end result will be 10. Proper time. The universal truth, not depending on the speed of any observer. Try this for yourself. So I think this is it, right? Oh yeah, of course you can go to the website here and then try it for yourself. Good. What's next? Oh, we're done. We're really done now. So if you want to know more about special relativity, I've created many more levels all the way. I build it up. The mathematics, the physics, everything. Here are the first 18. And here are the 19 all the way up to 34, the twin paradox. And you are now at 29C. So you're almost there. Next up will be level 30. If you just are interested in the headlines, you can skip those levels and go to level 31. But if you want to know another universal truth in the universe, it's the space-time interval. And we will look at it in the next level. I want to thank you for watching and hope to see you